Hi and a very good day everyone. Welcome to MTE and our virtual booth today. First of all, let's take a look at these three pictures over here. What do they have in common? Oil palm. Yes, they are all related to oil palm. Oil palm has been the main commodity crop in Malaysia, but the yields are affected by basal stem root disease caused by Ganoderma boninense fungus, as you can see in the middle picture over here. At the moment, we can control and detect the fungus infections, but we can't prevent it. What if we can actually get something out of the oil palm waste, such as the mesocarp fiber, to suppress the fungus? Wouldn't that be great? As the saying goes, prevention is always better than cure. If you are interested to know how, please stay tuned and we will share the innovation with you. The innovations that we have developed in MPOB is the protein hydrolysates from oil palm waste as an antifungal agent towards the Ganoderma boninense fungus. The basal stem root disease is the main plant disease that affects the oil palm plantations throughout Malaysia. This disease is caused by Ganoderma boninense fungus, and the fungus destroys the roots of young and mature oil palms. As a result, there has been a reduction in the optimum yield of palm oil by 50 to 80%, and this brings about an economic loss of 225 million to 1.5 billion ringgit Malaysia annually. The current practice to tackle the basal stem root disease is through control, manage, and detect. But is there any sustainable circular economic approach to handle this disease? Yes, there is. Now, the productions of oil palm waste in palm oil mill after extracting palm oil can go up to 110 million tons. And out of this amount of waste, 15% are mesocarp fibers. Hence, we have innovated the way the mesocarp fiber waste is being utilized by developing a process to extract protein hydrolysate from the waste. The protein hydrolysate is basically protein that are broken down to smaller fragments, and these fragments of proteins have antifungal bioactivity towards the Ganoderma boninense. And overall, the mesocarp fiber from the palm oil mill are treated with different enzyme formulations to produce the protein hydrolysate. The process is very much straightforward. The first step is to wash the mesocarp fiber waste, and the fiber will then undergo 2 stages of enzymatic treatments in controlled temperature environment. After just 10 hours, the protein hydrolysate is produced and you can use it directly. This process has also been filed for patent last year in 2020. We have done numerous antifungal tests in the lab, and these tests basically tell us that with a low amount of protein hydrolysate, we can suppress the growth of Ganoderma boninense for at least up to 10 days after we started to grow the fungus. We just need about 1 mg per ml of hydrolysate, and in this particular test, we were using 0.05 ml of hydrolysate to produce the suppressive effect. Therefore, through the innovations that we have done to the mesocarp fiber, we were able to add more values to the mesocarp fiber waste. Indirectly, we can help to diversify the income source of oil palm planters. More significantly, we are able to produce solutions or provide solutions to the basal stem root disease by protecting the palm trees. The innovation is sustainable as the waste is required is basically unlimited and free. The process to produce the protein hydrolysate can be seamlessly adapted to current palm oil mill workflow without any major disruption. Here, let us share with you the proposed adaptations to the palm oil mill workflow. The mesocarp fiber waste generated after extracting the palm oil can be channeled to the enzymatic treatments to produce the protein hydrolysate. A paper on this process is being peer-reviewed, and furthermore, we have initiated several R&D collaboration with local universities and companies to test the protein hydrolysate on the field, as well as to expand to other types of probe fungus in Malaysia. We are also working on upscaling the process. Last but not least, talk to us if you have any further inquiry, or even if you would like to collaborate with us to bring this innovation even further. We are more than happy to work with you. That's all from us today. Thank you very much.